Hey guys, how's everything going? This is Jay, sir. Let's solve another LeetCode problem today. It's 1868. Product of two round-length encoded arrays. Round-length encoding is a compression. Round-length encoding is a compression algorithm that allows for integer array nums with many segments of consecutive repeated numbers to be represented by a 2D array encoded. Each encoded is the value and its frequency. Describe the segment of repeated numbers in nums where this is value and this is the frequency. For example, this is an array. It could be compressed into 1 3, meaning there are 3 ones and 5 twos. The product of two round-length encoded array can be calculated using these following steps. Expand both into full arrays and get the product and compress and return it. You're given two round-length encoded array and the representing full array having the same length. Describe, return the product. Compression should be done such that round-length encoded array has the minimum possible length. Okay, so here's the example. This is encoded, so there are 3 ones, 3 twos. This one 3 6, 3 3. Expanded to this array, and then we get the product by multiply the items from both array, right? So this 6 6 6, so it's 6 6. There's another one. Expanded to expand to 3 ones, 2 2 3. And this one is 2 3 3 twos and 3 threes. Get the product and this, and then compress it to the I think get the I think we can actually just try to expand it. How can we expand it? Okay, expand it and get the product. Let's give it a try. So how can we expand it? I think we can create a function called expand array. So okay, this one is like encoded expand, and this one is return array. So let's leave it a to do like expanded equals expand encoded 1 expanded 2 expand encoded. Why LeetCode doesn't have this auto completion? It's pretty frustrating. But anyway, and then we will just get the product, right? So how can we get the product? And also we will compress, right? Compress array to do. And then we're getting another one like a get product array r2 to do. So what do? We just return, decompress, get product, expanded 1, expanded 2. Okay, we can actually put this in one call. It's pretty pretty straightforward. I guess it's what do expand. Okay, doing it right. It's not expand. Oh, okay, this one is one. Okay, so the first one is we need to expand it. Well, we can actually we get the item. It's pretty simple. Let's create a result array, and while this encode, are we able to modify this array in place? If not, we'll just use a for loop. Okay, const item. This one is number, and this is repeat. That's frequency. Okay, this one is num. This is frequency of encoded. We would just push to the result, right? Result, and while, oh, it's const. Let's just change it to let. While frequency 0, results we will push to none. Like if this is 1. Okay, if it is 1, we push 1 in and stop, right? So yeah, it's right. Okay, and then we just return the result. Great, and then compress. How can we compress it? By compress, we can actually do some count, right? We start from the first number, and the buffer is 1 1, and then if the following one is the same, we'll update the frequency. If we find a different number, we just push the buffer into the result, and yeah, in the end we'll push another one. So let's say like this one is a buffer. It's null. And for const item of array AR, just give it a better name. Okay, if buffer is null, we'll push it into 1, initialize it. Otherwise, if the number is the same, it's pretty tedious. We'll update the number, update the frequency. Else, then it means that it's different, right? So we need to push the buffer, and the buffer is a new one. Create a new one called item 1. Great, and once it's just done, we actually need to push another one, buffer. Am I right about this? If it is 1, we pushed. Oh no, wait a minute. There's a problem. So if there's only 1 item, we create a buffer. Oh yeah, it's right. Yeah, and then we can return the result. Okay, the next one is get product. Okay, let's. According to problem, there should be arrays of the same length. If it is not, we will throw. Array. Okay, the lists should have same length, and then we'll just get the result. We can just use reduce, I guess. Yeah, let's just reduce. I love reduce. Yeah, I'm joking. Item. I think there's an index, right? I guess. I'm not sure actually. Anyway, this one we will return the results. Return what? Return result plus item times the ARR2 index. Great. Let's give it a try. Bam. Yeah, of course, error is not errorable. Oh, wait, we forgot to return. No. Oh. Wait a minute. Compress. Yeah. We compress, get product. Shit. Yeah, it's not reduce, man. Sorry. It's actually map. Okay, AR map item index item plus AR2 index. Ugh, so stupid. Huh? Assignment to const. Yeah. I really like these TypeScript. At least the Monaco editor that gives me the warning. What? I didn't get it right. Okay, let's just debug just let's just verify our code. Okay, so we got this and this. We got 7, 1, 5. Oh, it's shit. It's not plus. It's times. So stupid. Again, we got 1. Why? Compress. Actually, we can't compress with map, right? So this, yeah. 1, yeah. If the buffer is the item, then we, oh shit, it's plus equals. Okay, it should work, I guess. Let's submit. This is the first time I submit it. But it should be TLE. That's my guess. Yeah, I think it's problem. It's not very performant. I guess so. So let's try to improve it. Okay, let's first comment out all the code. Let's analyze the problem again. So I think somehow we don't need to expand. This is some tricky questions. He says like you can expand, but we don't need to. Let's first analyze the first case here. This one. So actually, I think we can just try to get the product by the encoded item. So for this one, it's like 3 1s, there's 3 6. Obviously, the result should be 3 6, right? Because the frequency is the same. And then we get product at the next one. It's 6 3, right? And again, these are the same, 6 and a 6. So actually, we can get 6 6. Yeah, this one is pretty straightforward. Next one, this one. And this one. Let's first try to get the product first encoded one. This obviously is like 2 3, right? 3 2s. Okay, am I right? Yeah. The next one is 3 2 1 and 3 3. Here's the problem: is because they don't have the same length. We actually need to split this into 2. Like this one, and push the 3 1 back into the array, right? Just leave there. So this one will get us 6 1. And then again, this got 3 2 3 2. So eventually we will get to 3 6 1 9 9 2. So actually we can get the idea is we try to get product first items and splits the longer one, I guess, and merge. For example, if this is 6, I got 6 1. We need to, like this one, we need to merge, right? So merge by comparing the item. Do we have some edge cases like in the end? Yeah, we need to push the buffer. So yeah, I think we got I think I got a solution here. So let's create the results, and also we need the buffer. Okay, let's use let this time. Return results. Let's get the top item because they are the same length, right? We can just while, okay, yeah, I think we can just use while here. While encoded 1 length, there is item in the first array, and we will pop unshift. We first do unshift, like pop the DQ, like a Q, right? DQ the first item. So the head 1 equals shift const the 2 equals to the shift. So what do we do now? If they have the same length, okay, so if head 1 1 head 2 1, if they have the same length, we would get the result, right? So like the product equals head 1 0 times head 2 0. This one is head 1 1 because they're the same. This is the product, and if buffer is null, buffer equals product. Otherwise, we will check if the again check the number if they're the same. So if buffer equal, we have the same number, product 0, we would update the frequency. Otherwise, we will flush the buffer, push buffer, buffer equals product. Great. And oh, this isn't right. We actually need to normalize somehow. Otherwise, the logic here will be over and be repeated. Okay, so let's length. Okay, so length, comma length. Okay, length equals math the minimum 1 1 head 2 1. So if head 1 is bigger than length, we would push it back. So this will unshift, which is head 1 0 head 1 1 length, right? Okay, and then okay, we would need to update it. Head 1 1 equals length. We'll do the same to head 2. Head 2, push head 2, head 2. This is negative. Oh yeah. Head 2 length. Okay. So now head 1. Yeah, they should have the same length now. So we can get the product and push the buffer and go to the next one. In the end, so in the end, there is buffer. Yeah, there definitely will be one buffer there. And then we just need to push the buffer in. I think it should work. Let me just verify the code here. Oh, I think there's a. Oh, this one should be the same. Okay, let's go to the first one. First one, we will get the head 1, head 2. Length is the same, so this will be skipped. We would get the result, so it's 6 3 and 6 3. 6 3, buffer is null, product, and again 6 3, buffer is not null. The number is the same, so we plus it and push the buffer. Yeah, the first example is verified. The second one, we'll go to 1 3 1 3. We get 1 3 1 3. This is skipped, and we get what is it? 1 3 and 2 3. So 2 3. We get 2 3s. buffer updated. The next one is 2 1 and 2 3. Now we get the length is minimum, so it's 1. And we don't do anything for the first one, but for second one we would unshift like include the not enqueue, but yeah, it's enqueue. No, it's just the unshift. Okay, the second item, which is what 3 3, yeah, 3 3 3 2 in it, right? And then we will update it into 1. So they have the same length. Now we get the result, and the buffer, the top buffer, it's not the same. So we push the buffer and update the buffer. I think there is this problem here. Oh yeah, it's right. No worries. Yeah, I think it should work. What? Cannot read properties undefined. Reading 1. Wait a minute. This cannot be true because they have the same length, right? It says undefined. What? Okay, sorry. Let me log. Encoded 1, encoded 2. This is encoded 1, and this is encoded 2. So this is again. Oh, okay. So when we shift this out, yeah, this worked, but now we will shift this out. Okay, the minimum is 1. So somehow we unshift the first one. So this one is 2. Yeah, this is embarrassing. Okay, it should work, I think. Submit. Hope there's no TLE this time. Time limit exceeded. What? Can we do even better? Okay. I have a thing on this. Is shift is not good. I think we could actually do pop. Because shift, we still need to re-index the items, so it's not very performant. Let's use pop. So for this item here, let's just do it over again. So for this one, first we will check these 2 items because they have the same name. It doesn't matter which way we were doing it. So we will do 6 3 first. This 6 3 first, and this 6 3. 6 3. Because they're the same, so we merge it. It's the same. And then this one we will do it in an opposite way. So 2 3 2 3 3. So we will get what? We will get 6 9 2. And there's a 3 1 left here, right? And then we will get 2 1 and 3 1. So 2 1 and 3 1. It's 6 1. And the rest is 2 3. We will merge them, try to merge them and reverse it. In the end, we will reverse it so we can get it. Okay, so let's give it a try. So head 1, just to keep the name here, we just pop Not shift anymore. I don't think it somehow helped with the time limited thing. But anyway, we will push. For the buffer, we will do the same. Result push, and result reverse. Guess it'll work. Yay! Yeah, so the problem is on shift, man. Okay, great. That's it. I hope it helps. See you next time. Bye.